This video resource was created to support the implementation of the OCDSB scope and sequence topic representing decimal numbers in the junior grades. These are the specific expectations within the topic of fractions, decimals, and percents that are embedded within strand B, number, which will be addressed over the course of this tutorial. All junior grades read, represent, compare, and order decimals, grade 4 to tenths, grade 5 to hundredths, and grade 6 to thousandths. Many of the difficulties that students have with decimal numbers stem from the fact that decimals are primarily taught as an extension of the place value system. Understanding how fractional amounts can be represented as decimals in the base 10 number system is a key concept for junior grades. We can read and represent decimals in many ways: within words, standard notation, expanded form, and within base 10 pictorials or concrete. Comprehending decimal numbers is an important development in students' understanding of number. Having a deep understanding of decimal numbers can develop only when students have opportunities to explore decimal concepts concretely and pictorially, and to relate them to whole numbers and fractions. Developing a representational understanding of decimals depends on understanding of the base 10 number system, but developing a quantity understanding of decimals depends on developing fraction sense. Students need to be exposed to both to build this conceptual understanding. Using area models like this hundredths grid allows students to have time to investigate and represent base 10 fractions, which are fractions that have a denominator of 10, 100, and 1000, and so on. Base 10 blocks are useful concrete manipulatives for working with tenths and hundredths. For tenths, over here, the rod would be the whole, made up of 10 tenths, or 10 units. In this case, 3 tenths would represent the value of the yellow unit. For hundredths, the flat is the whole, and it is made up of 10 tenths, or 100 units, or we could call those hundredths. So the value of the green and yellow rods would be 21 hundredths. This wheel model will be familiar to students, as many have seen pies divided into thirds, fourths, tenths, and so on. These wheels are broken down into tenths. You can see here the pie pieces. And hundredths, the smaller flecks between the pie pieces. This model will be helpful for also graphing data and percentages as well. Number lines drawn with 10 or 100 divisions can help students make quantity comparisons between decimals and base 10 fractions, which visually helps students to order and compare decimals and fractions. Comparing and ordering numbers on an open number line, like this one, helps students to think about the relative size of the numbers being compared and ordered, and allows students to reflect on the proximity of the numbers to other significant numbers. A key concept from the curriculum is when representing decimals and fractions is that the one whole needs to be shown or explicitly indicated. Telling students what the whole is, or asking them from their own drawings, what is the whole, will determine how students will represent decimal numbers and/or fractions as it is relative to the whole. So here you can see 3 tenths is being shown, but in this case, the flat is the whole, and over here, the rod is the whole. Students need time to investigate decimals and base 10 fractions, which are fractions that have a denominator of 10, 100, 1,000, and so on. Both of these area models can be used to explore these decimals and fractions. This first model over here shows a thousandths grid which essentially is a hundredths grid, but each of these individual grids have been broken down into thousands. The second area model can be explained as 10 hundredths grids combined together to form one whole. Although area and base 10 blocks can be used to represent thousands, teachers should note that when representing thousands with base 10 blocks, students must define the largest cube as 1, or one whole. With whole numbers, this cube represents 1,000. With the large cube as 1, flats become tenths, rods become hundredths, and units become thousands. Although this three-dimensional model offers powerful learning opportunities, students should not be asked to redefine wholes in this way, as they can be very confusing. They need to have time first to have many rich experiences with the base 10 fraction. For example, now that over in this example, the whole is now a flat. So what are the value of the rods? Activities with base 10 blocks that frequently redefine the whole should be pursued only with students who have a firm grasp of the concept of tenths and hundredths. The meter stick is an excellent tool for thousands when it is marked with millimeter increments. The length of the whole does not change, and students can see that each interval can be further subdivided, decimeters into centimeters, centimeters into millimeters, while the whole always remains the same. The relationship between these unit lengths will assist students in measurement conversions further on in the year. Each centimeter is 1/100th, or 100th of a meter. It is important to give students opportunities to determine for themselves the connections between decimals and fractions with denominators of 10 and 100. That understanding can then be developed later on in the year with other fractions with different denominators. Instructions that is based on meaningful and relevant context help students to achieve the curriculum expectations related to decimal numbers. These contexts will help build student relationships and connections with later learning of percentages. Within the example that's given here, students have the ability to relate puzzle making to the concept of decimals and fractions. So when we say that we are going to build a whole puzzle, the completed puzzle is the whole. So as they start to develop this part-whole relationship, they start putting the pieces of the puzzle together. If you're working on a puzzle that has 100 pieces and you stop students partway through, they may have put together 34 out of the 100, or 34 hundredths of the puzzle. The pieces left to be made are the ones not within the puzzle, so these would be the ones left over, or 66 hundredths. This is establishing that part-whole relationship, and this can also be related to decimals and percentages. Money also provides a model for hundredths that students are very familiar with. It is important for teachers to make connections to the knowledge students bring to the classroom, but it is also important to know the limits of a particular model. Money amounts are usually represented to hundredths, but very rarely to 1 decimal place or 3 decimal places. However, when calculating tax, students will often be exposed to decimal amounts equal to or less than thousands, and it is here that we can integrate rounding decimals to the nearest hundredth. By asking students, what is your change, or how much more to a whole dollar amount, will foster that part-whole relationship between decimals and whole numbers. After students have had opportunities to compare decimal numbers using models and number lines, they can compare decimals using reasoning strategies that are now based on their conceptual understanding of place value. Students will be able to conceptualize, reason, and apply different methods to compare, order, represent, and solve decimal-related problems. You have to be careful, though, because as you foster this reasoning, you do not want it to become overly procedural. Students gain little understanding of quantity if they compare decimals by looking from digit to digit, as the student above explains her reasoning. So in this task, the student was asked to compare 15 and 1500s and 15 and 9/10. The student's reasoning was, I looked at the tens and they were the same. Then I looked at the ones and they were the same. Then I looked at the tenths, and since 1 is less than 9, 15.15 is less than 15.9. So as you can see here, procedural strategy was applied, but you'd have to dive deeper in questioning the student to see whether she has an understanding of the quantity relationship of those numbers. The professional resource that we use to create this video tutorial were accessed from the Professional Resource tab on the OCDSB Scope and Sequence. There you will find an extensive list of professional resources, including the Ministry of Education's key concepts and links to the Guide to Effective Instruction, along with other print resources that can be found in many of our OCDSB schools. The following resources should be in most OCDSB schools: Kathleen Fosno's Mini Lessons for Operations with Fractions, Decimals, and Percents, a year-long resource, Sherry Parrish Number Talk resources, and Marion Small's online Math Up resource, among other resources. All provide a bank of topics, prompts for daily number sense routines.